Hi, I'm Joseph Bolduc, and my ASC project is an automated Nerf Sentry gun. What it is a Nerf gun that can automatically aim and shoot at people. I was mainly inspired by this Linus Tech Tips video where they make a Nerf gun on a stand that can track faces and identify them, and then aim this massive Nerf gun and shoot at them, and the Sentry gun in Team Fortress 2. The original intent of the project was to have this be used in Nerf Mafia, but I didn't have it done in time, and there were a couple issues with powering the Raspberry Pi remotely using lithium-ion batteries, which aren't exactly cheap. Although my project didn't really turn out the way I wanted it to, it was still pretty fun, and I learned a lot on the way. For example, I brushed up on my CAD skills. Thank you, Mr. Lee. For the first time ever, I designed models with 3D printing in mind. I learned how to use image recognition using OpenCV, and I used a Raspberry Pi to control all the servos and stepper motors that I used for the project. And I have a 3D printer now, and I use that for a lot of the stuff in this project. And it was a lot of fun optimizing and making sure that the models would print correctly, because you can't use the certain shapes as you could in other manufacturing methods as you can in 3D printing. Although the advantage of 3D printing, of course, is that I don't have to set up a whole factory tool chain to print out one thing. So I don't have to bother Miss Fuller to 3D print stuff for me, which is nice. Well, this is the part where I show you what I've done so far. Well, I guess I'll start off with the 3D models I made. The software I used was Fusion 360, which offers a free student license, although I believe I just used the free trial. This is the absolutely first thing I did, which is the base, although this is a second iteration of it. The first one, I kind of just edited over this. Let's see, we can turn on all the bodies here, all the legs. So this is how it looks like in CAD. Whoops, I never actually used this pan shaft up here, so I'll just get rid of that. And I have all these legs in here, and they fit in the bottom like this, and then they screw in. And then there's a cap that goes on top and holds it all in place. This thing's actually pretty strong, although looking back I should have made this base a bit wider to make it more balanced. Next up is yes. Here's something pretty simple I made a long time ago. It's the enclosure for the stepper motor. This just goes on the bottom of the main chassis, but you can see that later. Yes, these models. They're from way back when I tried to make my own Nerf gun using flywheels. I started off with 2 DC motors, which I salvaged from some random RC car, which I wasn't using anymore. As you can see, I kind of had a circle cut in here, and then these would spin on this little contraption right here. Except it didn't actually work because the motors I was using weren't that good, and the darts, I didn't really have a reliable way to feed them into this hole. So that ended pretty quickly. To attach the things to the Nerf gun, I'm using the built-in attachment rails. Here's one of the first tests I did. I still have the green color from the accessibility analysis on, but it pretty much just slides on, and then you have these 2 holes here, and it does not go anywhere. Here's the rail attachment for the servo. It prints upward like this. I didn't end up using this top part. This top part up here. And the way it works is it just slides in there, and then you can see one side is longer than the other because that's how it is on the Nerf gun. I had to measure that out. And then this is where the servo goes into, and I just drill in the holes on here. And then here is the puller. This pretty much just goes on the servo head. This fits pretty snugly, which I'm happy this design worked out so well, and it pulls the trigger on the Nerf gun. Here's the first iteration of the chassis that I used. It's pretty bad in my opinion. It uses way too much plastic. For example, these things right here, they're way too thick, and there's all this area down here that doesn't get used. And the bearing didn't quite fit, and the print quality left a bit to be desired. An upside is that I learned, I figured out how to use, how do I find it? Section analysis. Inside here there's a little, whoops, that was too far. Come back. There's a channel in here that this cable runs up, and then they both run up on top, which is really nice.
But I never really utilized these in the final design.
Here's the first iteration of code that I wrote for the project. It's Arduino code and not Raspberry Pi code, which means it's in C. As you can see, it's pretty simple. It just has one servo class, and then it moves it around. And this is the trigger servo, because that's what I did first. The second iteration of this is this, which lets it move around and can fire it. Although I don't have the stepper motor set up at this point, because I would do that in the Python code for the Raspberry Pi, which comes later. So this is the code that I wrote for the Raspberry Pi. It's in Python, and it uses the PygPio and OpenCV libraries to actually do stuff. And I just realized that I forgot to explain what OpenCV and PygPio are in my video. OpenCV is an open source library for Python and Java that allows you to import photos, whether it be from a webcam, pre-recorded video, or just stored photo images, and process them with their suite of computer vision tools. I'll explain a bit more in the video. And PygPio, or PyGPIO, is a library written for the Raspberry Pi to control the servos. What I'm mainly using it for is to generate pulse width modification signals to control the servos. If you don't know what those are, it's a signal that alternates between 0 and 5 volts, like very rapidly, about 1,000 times per second, and depending on the width between the pulses, it would be on or off like a certain percent of the time. And that's what causes the servo to move like a certain percent of the way, like on the thing. I'm also using PygPio to control the stepper motor as well, by having it write to the pins on the Arduino, have it write to the pins on the Raspberry Pi, because you can't do that just with Python on its own. Me from the future, out. And if you're wondering why this looks like Linux, it's because this is Linux. This is running through screen share because my Raspberry Pi is across the room from me, and to write code on it I just use the screen share and then open up Visual Studio Code on the Raspberry Pi. But anyway, what this code does is it controls the servos and stepper motors, but the actual meat of the code is down here in this ugly while loop. What it does is detects if a frame has a face using what's called a Har cascade. You can see, get out of the way. You can see it is initialized here. And what a Har cascade is it's a really lightweight and easy way to detect certain objects in a picture. An upside and downside to it is that they're pre-trained, so you can't really change them, but they're pre-trained, so you don't have to train them yourself. This code pretty much just draws a box around the face and draws a little crosshair on it, and depending on that, and depending on where the face is in the picture, it will move the servos to point to it. And here's a video demonstration of what the camera sees, and here's what it looks like tracking faces. This is the old version, by the way, when it was still a cardboard box, but that got fixed, trust me. And here it is. I don't have the face tracking hooked up because running it alongside with like the movement is too slow, but I'm here just moving it around with this joystick here, and the stepper motor for the pan is really quiet actually. And the movement with the servos, it took quite a bit of work to get right. And to fire it, I'll show you that in a second with the camera on it. But this is what it looks like. Yes, as you can see, there is some duct tape here. These screws, unfortunately, they were stripped, so I couldn't get them in all the way. And the ones I printed out in like the actual red part were a little bit too big, so I couldn't get that, and I couldn't reprint it in time. And here is the way it fires right here. This pulls back on the trigger here. Unfortunately, I didn't have enough time to hold this down in any fancier way, but this is it. Here's the other side. It can, I was originally planning on having all this wiring here placed up front, but with it there, it weighed too much for it to move properly. Although having that there would have been nicer because it's currently restricted in how it can turn left and right because these cables are stopping it, obviously. This video is getting quite long, so to wrap things up, I had a lot of fun doing this project because I learned a lot about software and electronics. While I'm kind of disappointed that I couldn't get the face tracking to run while moving the motors around because the Raspberry Pi just doesn't have enough strong enough CPU, this project was still pretty fun and I learned a lot. Thanks for watching my presentation.